Hello friends and followers. By now you've seen my last videos on the Drake PS7 power supply. So the transistors for this thing finally came in, and these are the major pass transistors. So I did go ahead and replace them all. And that's nice. Two of them were directly shorted. So how can you tell if a transistor is shorted? Well, these are the transistors that were in the unit. They look like they're Texas Instruments 2N5301. These things were shorted on base emitter collector, all shorted together. I just don't understand why they're all shorted together. This thing was just sitting here running and it just stopped, and the crowbar circuit went on because the voltage went real high on the output. And I was like, why would it do that? So anyway, the story gets deeper and worse. So anyway, how do we check a transistor? You first put the meter onto the transistor check mode, which is in this case a diode symbol on this old fluke meter here. Then you can take your probes and put them together and see if it'll make a beep. It should. Let's do that. Get some of this junk out of the way here. There we are. Okay. Okay, that's a short. You don't want to see that. Now you can take these probes and this is an NPN, so you can put the positive on the base. And let me put the phone down here if I can. Phone. There's the camera, and it's down. All right, that's good. So let's give a lesson on how to test a transistor. Well, you find the base on this one, and this one's labeled emitter, and the B is the base. The base is here. Anyway, this is NPN. So you put the positive on the base, and then you should get like a short beep here if it's a good transistor. This one gives a long beep, so it's shorted. And here too. And then when you go emitter to collector, it should be open. And this one is shorted. So I don't know why it's so shorted, but it is. So we'll throw it in the wastebasket. Okay, and then this one is the same, I think, type. It's a TI, right? Yeah. Anyway, this one survived. I changed these all to N5303s, which I think have twice the voltage capacity as far as the PIV volts, instead of 40 volts or 80 volts. So I changed all these to the classier transistor, which was probably more expensive in 1979. But anyway, here we go again. So let's check this one out. Here's the base. You can read the base on this one. It says B. Right about there's the B right there. We'll put the positive here on the base. It's an NPN. Should get a short beep. Short beep. And okay, yeah, I'm getting .479 on that end. Collector is always a bit lower. Collector, I'm getting .475. So that works fine. And actually, let me show you the meter here so you can see how that works. So here's the meter I'm using. And here's the transistor. So yeah, when I do these, you can see how it works. So I go to base positive for NPN. The base is now positive with the positive lead. I guess you can't see the red. There it is. We'll hit this one here. You see the .477, 47. What do we got there? 47 what? 475 on the collector. The emitter is going to be a little higher. The emitter 479. Collector 476. Now, if you reverse it and put the negative lead on the base, it shouldn't do anything. There should be no beep. If it does beep, you're in trouble. So let's try that. Negative on the base. And we'll just go around and hit the collector, nothing. Hit the emitter, nothing. Okay. And then the last check you want to do is do the collector to emitter. So you can put one lead on the collector and one lead on the emitter, which is the E wire here. That should not beep or do anything, and it doesn't. So This transistor is a good guy or a good gal. The other one is bad. So that's how you check them. Anyway, back to the story at large. So this thing has been a tale of woe for me, just a tale of woe. So I did replace all these. I think I spent 2 hours replacing these. I had to wrench those out with a small socket wrench and kept dropping bolts and losing things. And this one in here was really hard because it's buried in there. And then these little covers, you can't really get these off with a screwdriver. So you have to wrench these loose. The covers will pop off. Then there's these are regular screws here. And this little plastic insert's a spacer with little, I would say, little tongs to keep the thing centered. So this spacer comes out. And then you can take these collector wires off, take the small base wire off, take the large emitter wire off, and replace your transistor, and you guys solder them back in. So they aren't socketed, they're soldered. You can see the solder connections on these. So it takes a lot of time to clean up this amplifier, our amplifier power supply. My other notation is that there wasn't really any heat transfer compound on these. No silicon compound, no nothing. It had like a weird, I reused the silicon, it seemed like a nylon or something, insulator, and I dabbed these with some of this stuff. So I put some good stuff I used to fix Apple computer heat sinks on it. I used this to heat sink these things, but it didn't seem like anything was on these at all. But still, I'm not sure why 2 of these are blown out. So I think this is blown out here, and one back here was blown out, completely shorted. I'm not sure why they would short like that. Anyway, these are all commanded by this little tip transistor here. So these all get drive from this guy right here. So he or she or it drives those past transistors, and that's how that works. And then we have this board here. So this board has been a pain in the Budinsky. So I don't really understand this old voltage regulator in here. The same thing was in the Tech 444 amplifier, the same voltage control chip. Anyway, I bought a bunch of these to fix my amplifier, which I couldn't fix, as you know. So I basically then put a socket in here, put a new chip in there, just because I don't want to screw around with it. And here we have 4 little diodes, and this thing is really an external control power supply. So they have a bridge circuit here, and it's on the lower, so on the very lower contacts here, these go right to this bridge circuit, and the lower contacts are a separate winding off this huge transformer in here. So you'll see the big nasty transformer in this power supply that makes it weigh 40 pounds or something. Anyway, there's 2 yellow wires here that come off the transformer, and you'll see them right here at the very bottom. These yellow wires are what powers these diodes, and I can measure 19 volts on those wires. This capacitor here, this large capacitor on this board, is basically right off those diodes, and so I measured across this thing. I'm getting like 0.4 volts. So there's some kind of weird problem on this board. Something shorted, I don't know. Or else these diodes are bad. These could be bad. They check good, but they could be bad, I don't know. So I want to tomorrow jump the 12 volts or 20 volts into these 2 pins and then probe around and see why this board's bad. I need to get 12 volts of power or some amount of power coming off this capacitor here to feed the circuitry here to get this thing to go. Once that fires up, this past transistor will fire up, and then it'll fire this past transistor here, and then it'll run all 4 of these. So that's how that works. And they do some feedback from these guys into this little chip to regulate the voltage. I think this yellow one is voltage, this one's current. So I'm really looking forward to getting this thing working again, but it's been painful. A lot more painful than it should be. All right, well, that's my little video. Tomorrow I'll continue on this thing. I'm too tired. My back is killing me. It's time to go to bed. Thanks for watching. Have a great day.